All right, so what is actually happening, that we are looking for all those applications in which the machine which is being used is having a processor in it, and we will actually understand later that the processors, inside the processor there are registers. So those registers are actually responsible for the working of processors. So registers have special duties. So not just those computers which are full-fledged computers like desktop, laptop, cell phones, tabs, but those computers which are made for a special purpose, जैसा कि AC है, गिटार है, organ है, oven है, गाड़ी का computer है, they all are using registers in it. But the ability of those processor is just confined, limited to that particular device. That device might be a robot for a particular purpose. That device might be a digital instrument like a guitar or an organ and whatever. And the counting system. Counting system means the display of your watch, a display over your AC, a display over your car console, whatever. So counting system where you are watching time or counting or any numbers. All right, like speedometer. If your car has got speedometer which is digital, so it must be showing numbers. So those numbers belong to the counting system. All right. Now, अब देखें ये जो टॉपिक है इसको समझने के लिए it is absolutely necessary कि हम लोग जो हैं वो नंबर्स को समझें. नंबर्स हमने लास्ट 2 वीक्स में डिस्कस किए हैं और समझे. अब उसकी रिलेशन से हम इस वाले पर्टिकुलर टॉपिक को अंडरस्टैंड करेंगे. देखिए, अब ये क्वेश्चंस हैं, काफी सारे क्वेश्चंस हैं, इनको हम आहिस्ता आहिस्ता करके सॉल्व करते हैं. आज हमारा जो टोटल फोकस होगा वो सिर्फ और सिर्फ इन वाले नंबर्स पे होगा जो कंप्यूटर के रजिस्टर्स के अंदर होते हैं और वो कंप्यूटर को कंट्रोल करने के लिए इस्तेमाल होते हैं. So a 7 segment display, why do we call it 7 segment? अगर आप अपने एयर कंडीशन की तरफ देखें तो एयर कंडीशन के ऊपर आपको ये digits नजर आएंगे. These digits are made up of 7 parts, 7 segments. So 1, 2, 3, 4, 5, 6 and 7 segments. All right, so 7 segment display. Now this 7 segment display is related to a computer register. Computer uses this register to control this 7 segment display. All right, so this 7 segment display is actually related to this register. So why do we call it register? Because this is a physical thing. This is a physical thing and this acts like switches. जैसे आप अपने कमरे में दाखिल होते हैं तो you look at the switchboard. Every single switch is actually related to one electrical appliance in that room or one electric gadget in that room. For example, one switch is for fan. So आपने जब on किया तो fan on हो गया, फिर आपने off कर दिया for light and for other things. So basically ये switches हैं. All right. अब इन switches के साथ जो relation है वो इस device की इस तरह है कि अब जब आप इन switches को manipulate करेंगे तो device accordingly act करेगी. So the program, the remote control or the computer program that you will write will not be actually for the output but for the control of these registers. So जब आप इन registers में devices में register devices के अंदर अपनी मर्जी से bits को ऊपर नीचे करेंगे तो ये डिवाइस की आउटपुट पे असरअंदाज होगा. ठीक है, अब इसका क्या मतलब है देखिए. अभी कहता है कि 7 segment display is used to indicate which floor a lift is on. Each segment is numbered as shown. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. And these are related bits in this particular register. अच्छा, जब हम register की बात करते हैं, तो it is not necessary that that register is just made up of any combination of bits in multiples of bytes. No, that register can be made up of any number of bits. That can be 4 bits, that can be 8 bits, that can be 10 bits, that as per the requirement. As you would have seen that हर कमरे में switchboard के अंदर एक equal number of switches नहीं होता. So if there is a big hall that has got so many lights, so it would have so many switches. Similarly, if it is a small room that has less lights in it and one fan in it, it would have less number of switches. So as per the requirement of that particular machine, the size of the register is defined, and the register is a physical thing and it is made. All right, so register is actually the smallest memory inside the microprocessor that has some work related to it. All right, okay, अब देखिए. Now a byte is used to hold the data needed to light the current segment. Bit 0 is always 0, so this 0 will always be 0 no matter what. So just think that it is not there. All right, just think it is not there, so just don't mind. Now if you like to make this 7 segment display to show 3, so it means that 6 will be 0, 5 will be 0. So 6 and 5 are 0, and 1, 2, 7, 3, 4. So 1, 2, 7, 3, 4 will be 1. 1, 1, 2, 7, 3, and 4, they will be 1, and rest will be 0. So similarly, अगर आप इसमें से 2 बनाना चाहते हैं, तो 2 किस तरीके से बनेगा? 2 बनेगा 1, 2, 7, 1, 2, 7, 5, and 4, and rest will be 0. So ये आपके पास 2 बन गया. That is how the whole thing is actually made. अब देखें आगे क्या है. First byte is this. So this is 1, 2, and 3. So what is 1, 2, and 3? 1, 2, and 3. So this is 7. And over here it is 1, 2, 3, 4, 5, 6, 7. So 1, 3, 4, 6, and 7. So this is 5. Get the idea? That is how computer is using this particular register to create digits out of this 7 segment display. So this is 7, this is 5. What pattern is used to indicate floor 2? I told you that this is 2. This is 2. So we have 1, we have 2, we have 7, we have 5, and we have 4. So 2 would be 0, 1, 1, 0, 1, 1, 0, 1. This is 2. Floor 2. Okay? So that is very simple. Let's move forward. Another question. Electric guitars consist of strings and frets. So these are strings, 1, 2, 3, 4, 5, and these are frets, the parts of the string. Okay, so these are frets. So it says that there are 6 strings over here, 1, 2, 3, 4, 5, 6, and there are 22 frets, means these parts are 22. Okay, so get the idea. Now music notes on the guitar can be represented using a tab notation. A tab notation is basically a register of 6 bits. A tab notation is basically the register of 6 bits. Okay, so this is a register of 6 bits. Now this basically 0, or this, it corresponds to this bit, this one corresponds to this bit, this one corresponds to this bit, and then we have got this 4, then this 5, then this 6. You will actually have to pay attention to either the top is being represented by the bit on the least significant side, or the top is being represented by the bit on the most significant side. So we have realized that the top is being represented by the least significant side. So this is least significant side. So it means that, अब देखिए यहाँ पर musical notes on the guitar can be represented using a tab notation. Each line represents a string. All right, so this is a string 1, 2, 3, 4, 5, 6. As they said that there are actually 6 strings. So these are 6 strings over here. 1, 2, 3, 4, 5, 6. Okay, so 6 strings. So 6 string, every single string is being represented by its bit in the register. Now, what is the purpose of this? The purpose of this is when you play music on this guitar, the guitar will record that into the register. Guitar will record that into the register. This is beta past topicals for chapter 1.1.1. All right, just listen to it. Just don't ignore anything. Just listen to me what I'm saying. So this 0 is placed here. This 1 is placed here. This 1 is placed here. This 0, 0. And this 1 is placed over here. Say it. And then this is the tab notation. Now it is also important to indicate where the string should be held. Means आप अपने fingers को use करके इन strings को press कर रहे हैं. जब आप इन strings को press कर रहे हैं, तो that press should be on a particular fret. So which fret it is, it will be represented using another register. So there are 2 registers. First register is showing that which string is held. The second register is actually recording that at which particular fret the part which is made over the handle of the guitar is actually being used to press those strings. Now, over here they were using it like 1, 2, 3, 4, 5, 6, but over here they are using it like a number. 2 to power 0, 2 to power 1, 2 to power 2, 2 to power 3, 2 to power 4, 2 to power 5 as 6 bits. All right. So which fret is this? 20th fret. So it means that 16 plus 4. This is 16 plus 4, which is 20th. So this is being used. The other register is being used like a number. The first one is being used like a switch. All right, so and these 2 registers are being used to actually control the storage which is being generated when we are actually playing the guitar. जब हम गिटार को play कर रहे हैं तो वो जो भी data है वो इन 2 में store हो रहा है. अच्छा, अब देखें यहाँ पे क्या हो रहा है. A note is being played according to the tab notation this. Now we know that this is actually 1. So this is 1, this is 0, this is 1, 1, 1 and 0. So this is 1, 0, 1, 1, 1, 0. So this is our tab notation. As the first string is being represented by the first bit and so on and so forth. So it goes downwards over here and backwards over here. All right. So now, which fret is this? This is 18th fret. So 18th means 16 plus 2. This is 18. All right. So string number 1, 3, 4 and 5 is being pressed at the fret 18 over here. ठीक हो गया? Now it says that show on the diagram below which note corresponds to tab notation this. So this is 0, this is 1, this is 0, 0, 0, 0 over here. So this will be like this. Okay, so 0, 1. So as we know that whenever it is 1, तो यहाँ पर हमें डॉट लगाना है. It means it is actually representing the finger is pressing this particular string. Okay, so ये आपको जो है यहाँ पर समझ में आ गया. अब हम आगे चलते हैं. What fret position corresponds to this? So this is like 0, 1, 0, 0, 1, 1. So this is 1, 2, 4, 8, 16 and 32. So this is 16 plus 2 plus 1. So this is 16, 17, 18 and 19 position. All right, so all you have to write is just 19. You don't have to actually do this. So whenever it is fret position, it is actually acting like a number. All right. Describe 2 advantages of storing musical notes in this format. All right, which format is this? This format means digital. So I would like you to understand this particular question. Like it is saying that what is the difference between typing a letter over the typewriter or in Microsoft Word? So this question corresponds to that question. This is like question. तो हमें क्या फायदा मिलेगा कि अगर हम टाइपराइटर पे टाइप करने के बजाय वर्ड पे टाइप करें तो हमें क्या क्या फायदा मिलेगा? We can edit later. We can create copies. We can create variations in digital copies. We can share like email or Bluetooth transfer or WhatsApp the digital file. Computer software can improve the recording. It is like when we type, we can commit few spelling mistakes, isn't it? तो कंप्यूटर माइक्रोसॉफ्ट वर्ड क्या करता है, वो स्पेलिंग मिस्टेक्स को आइडेंटिफाई करके रिमूव कर देता है. तो यहाँ पर भी होगा कि जब हम म्यूजिक प्ले कर रहे हैं, if there is something which is going wrong, so software will indicate or correct it itself. All right. So these are all the same. तो आपके पास जब भी ऐसा कोई क्वेश्चन है, देखिए इस क्वेश्चन का ताल्लुक आपके सिलेबस से नहीं है, इस क्वेश्चन का ताल्लुक है आपकी अंडरस्टैंडिंग से. वो क्या है कि जब कोई चीज फिजिकल होती है तो हमारा कंट्रोल उस पर इतना ज्यादा नहीं होता. जब कोई चीज डिजिटल होती है तो उसमें हमारा कंट्रोल बढ़ जाता है. हम उसको शेयर कर सकते हैं, दूसरे को ईमेल कर सकते हैं, व्हाट्सएप कर सकते हैं, ब्लूटूथ कर सकते हैं, वाईफाई से ट्रांसफर कर सकते हैं. जब वो डिजिटल होती है तो वी कैन क्रिएट कॉपीज, we can create variations, we can let the software to fine tune it. That is all possible. Okay. Or lastly, we can replay the music as per our will without actually be playing over the guitar. What does it mean? If you like to replay the music, all you have to do is to double click the digital file and it will be replayed. हमें बार बार गिटार बजा के नहीं उसको सुनना पड़ेगा. It will be already recorded. Now, the next question. A digital alarm clock is controlled by the microprocessor. It uses 24 बेटा दिस इज वेरी सिंपल. देखें आपको ये सिनेरियो जो है इसमें इन्होंने कहा सर ये समझ नहीं आया, सर ये नहीं समझ आया, डिफरेंट राइटिंग स्टाइल्स फॉर फास्ट वर्किंग. यस दैट इज ट्रू. अच्छा अब देखें समझ में आना शुरू हो जाएगा. यहाँ पर सिर्फ ये है कि इन्होंने गिटार किया तो गिटार को 2 रजिस्टर्स में सेव कर रहे हैं कि कहाँ पे आपने प्रेस किया और किस पर्टिकुलर फ्रेट पे प्रेस किया और कौन कौन से स्ट्रिंग्स प्रेस किए. तो स्ट्रिंग को प्रेस करने के लिए अलग रजिस्टर है और उसके बाद जो है वो जिस लोकेशन पे किया उसको अलग रजिस्टर है. तो स्ट्रिंग को स्ट्रिंग नंबर से सेव कर रहे हैं और फ्रेट को जो है फ्रेट की पोजीशन एज ए होल बाइनरी नंबर से सेव करें. आप अगला क्वेश्चन देखिए या आपको ऑटोमेटिकली समझ आने शुरू हो जाएंगे. A digital alarm clock is controlled by a microprocessor. It uses 24-hour system. So 6 p.m. is 1800. Each digit in the typical display is represented by a 4-digit binary code. It means that this digit corresponds to this register, this digit corresponds to this register, this digit corresponds to this register, and this digit corresponds to this register, and these registers are having just 4 bits. So 1, 2, 4, 8. So how will you come up with 0? So this is 0. How you will come up with 8? 1, 2, 4, 8. How you will come up with 3? 1, 2, 4, 8. How you will come up with 5? 1, 2, 4, 8. So these are being stored over here. These are being stored over here. So this is 0. 0. So 0, 0, 0, 0. ये 0 हो गया. This is 8. 1, 2, 4, 8. This is 0. This is 8. This is 1 plus 2, 3. This is 1 plus 4. 1, 2, 4. This is 5. So similarly, if we go this way, so this would be 1. This would be 2 plus 4, 6. This would be 1, 2, 4, and this would be 8 plus 1, 9. 1 plus 8, 9. So this would be 1649. All right, so this is 1649. The time is shown this way. So one digit is being controlled by 4 bits. One digit is being controlled by 4 bits. Get the idea? That is how the clock is being displayed. Now, this is 1. So this is 1, 2, 4, 8. This is 1. This is 7. So 4 plus 2, 6 plus 1, 7. So this is 7. This is 2. So 1, 2. 4, 8. So this is 2. This is 9. So this is 1, 2, 4, 8. This is 9. 8 plus 1, 9. This is 1729. All right. So 1, 7, 2, 9. The question is how we will know that this particular bit corresponds to the first register and this one corresponds to last register. So this you will get from the example given in the question. Question में आपको इस example में खुद ही बताया गया. देखिए यहाँ पर ये जो example दी गई है इसमें हमें पता चल रहा है कि 0 जो है वो first register है और 5 जो है वो last register है. तो हम सारे questions को उसी तरीके से answer करेंगे. Now, ये जो क्वेश्चन है, the clock alarm has set at 8. Describe the actions of microprocessor which enable the alarm to sound at 8. Beta, this question belongs to another topic which is called monitoring and control. तो जब हम chapter 3 hardware में monitoring and control पढ़ रहे होंगे उस वक्त मैं आपको ये समझाऊंगा. This has nothing to do with registers and all. So since this is part of this particular question, so that is why it was here. So we will skip it. Now, this question is a good one. A vending machine has the choices shown below. Now, what is a vending machine? A vending machine is a machine where we put money and we choose which item we need to have, and then that machine gives you that item. It drops that item into the compartment underneath the machine so that you could pick it up. So automatic shop selling. That is vending machine. So हम सब ने vending machines देखी हैं. कुछ स्कूलों में like Beacon House में तो मैंने देखा है, FPS में मैंने देखा है कि ये vending machines are part of it. So there is a vending machine और इस vending machine के अंदर जो है ये options आपके पास आ रहे हैं. ठीक है, इस vending machine में ये options आपके पास आ रहे हैं और ये options क्या हैं? If you press 10 you will get tea. If you press 11 you will get tea with milk. If you press 12 you will get tea with sugar, and if you press 13 you will get tea with milk and sugar. Similarly, same with coffee, same with hot chocolate, same with cold water, hot water, fizzy water. 50 is Coke, orange, lemon. So pay attention to these menus. Okay, now it says that a customer uses a keypad. Keypad is like your cell phone keypad or your ATM keypad. Keypad is actually something like this area. So just this area, the numbers. All right, so this is a keypad. Keyboard's keypad. So this keypad is having a register attached to it. So with that register is actually taking the number which is being pressed over the keypad. Now, a customer uses the keypad to make their choice. Each number entered is represented in a 6-bit binary register. So 1, 2, 3, 4, 5, 6. So this is a register which is actually taking an input. Now over here, before we go any further and try starting solving this question, I will like you to remember what is range. Range is the highest number that we can have. Range is the highest number that we can have in a given number of bits. So range over here is actually 2 to power 6. So that would be 64. So the smallest number that you can have is 0 and the largest number that you can have is 63. So it means the range is kind of from 0 to 63 for a register which is having 6 bits in it. All right. So इसको ज़हन में रखिएगा कि हमारे पास जो range है for this 6-bit register is, we can say from 0 to 63, means 64 different numbers. Now, a customer uses a keypad to make their choice. Each number entered is represented in a 6-bit binary register. For example, key press 33 hot chocolate with extra milk and sugar. So hot chocolate with extra milk and sugar means 33. So this is 32 plus 1 is equal to 33. So this is 33. Hot chocolate with milk and extra sugar, that is 33. Okay, get the idea? Now, if a customer chooses coffee with milk and sugar, what is the key press? If a customer chooses coffee with milk and sugar. So coffee with milk and sugar is actually, 23. All right. So we will be saving 23 over here. Now, how it is represented in 6-bit register? So 16 plus 4, 20 plus 2, 22 plus 1, 23. That is how you can save it. All right. So 23, 16 plus 4, 20 plus 2. So this is 16 plus 4 plus 2 plus 1, that is 23. If the 16-bit register shows this, so what is this? 1, 0, 1, 0, 0, 1 means 1, 2, 4, 8, 16 and 32. So it means that this is 32 plus 8, 40 plus 1. This is 41. All right. So this is what? 41. So let's see what is at 41. 41 is actually hot water. So this is hot water. What drink has customer chosen? Hot water. 41. So you will, now I hope that it is making sense to you, the registers, the use of registers. Now, a customer using the vending machine gets an error message after keying in their selection. What could have caused this error message? Now, this means that there is a possibility of errors. So a customer has entered a number and system has given an error. What that error could be? Obviously, the number that is entered is not the right number. What does it mean, right number? Means not, number is not from this list. काउंट एरर में भी बेटा काउंट एरर नहीं, एरर ऐसा एरर जो कि आपने उसमें रेंज में दिया ही नहीं है, आउट ऑफ रेंज कह लें आप उसको, सही कह रहे हैं आप रमीज, आप आउट ऑफ रेंज उसको कह लीजिए. लेकिन द थिंग इज दैट अगर आप इस सीक्वेंस को भी देखें तो 10 से पहले और 13 के बाद 20 तक कुछ नहीं है, इसी तरीके से 20 और 23 तक है, फिर 23 के बाद 30 तक कुछ नहीं है, फिर 30 से 33 तक है, फिर 33 के बाद 40 तक कुछ नहीं है, फिर 40 है, 41 है, 42 है, बट 43 नहीं है, फिर 50 है, 51. सो अ नंबर, आपका जो आंसर होगा वो ये होगा, द मेन्यू नंबर that is chosen does not exist. The menu number that is chosen does not exist. That's why system has generated error. Get the idea? So the menu number that is chosen does not exist. That's why the system has generated an error. Good. You got it. अच्छा, अब हम वापस आते हैं अपने आइडिया ऑफ रेंज की तरफ बेटे. रेंज में मैंने आपसे क्या कहा था? रेंज में मैंने आपसे कहा था कि हमारे पास रेंज है, 6 बिट की जो रेंज है वो है 0 to 63. तो अब देखें मैं क्या बताने की कोशिश कर रहा हूं. अगर हमारे पास 1, 2, 3, 4, 5 और 6 बिट्स हैं तो हम इसके अंदर सबसे छोटा नंबर जो सेव कर सकते हैं वो 0 है, और सबसे बड़ा नंबर जो सेव कर सकते हैं वो है 63. लेकिन अगर हम इन दो अगर हम इसको ब्रेक करें यहां से, तो ये बन जाएंगे 3 बिट्स 1 और ये बन जाएंगे 3 बिट्स 1. ये देखिए सारी लॉजिकल डिवीजन है, मतलब स्टोरेज इज देयर, हाउ सिस्टम इज एक्चुअली ट्रीटिंग इट. तो जब ये मिला के हम देखते हैं तो हम 0 से 63 तक चले जाते हैं. अब जब हम इसको अलग अलग देखेंगे तो इसका मतलब होगा 2 की पावर 3 मीन्स 8। इसका मतलब ये हुआ कि हम 0 से 7 तक जा सकते हैं। इसका भी मतलब यही हुआ 2 to power 3 is 8 मीन्स फ्रॉम 0 to 7। सो इट मीन्स कि हम इसके अंदर 0 से 7 तक जा सकते हैं। हम इसके अंदर 0 to 7 तक जा सकते हैं। ऑलराइट, सो इसका मतलब ये हो गया कि हम हर एक में 0 से 7 तक जा सकते हैं। तो इसका मतलब ये हो गया कि हम यहां पर कोई भी नंबर इस 6 बिट के अंदर क्रिएट कर सकते हैं जो कि 0 से 77 तक का होगा। व्हाट डज इट मीन? यहाँ पे आप देखें, आप यहाँ पे लिखें 0, यहाँ पे आप लिखें 0, इसका मतलब है हम 0 से 7 तक यहाँ पे भी लिख सकते हैं, यहाँ पर भी लिख सकते हैं। तो इसका मतलब ये हुआ कि 0 0 0 1 0 2 चलते चलते आप कहाँ तक जा सकते हैं? 77 तक। अब इस पूरी चीज को हम समराइज करते हैं कि व्हाट आई एम एक्चुअली ट्राइंग टू टेल यू। आई वॉज टेलिंग कि अगर हमारे पास एक रजिस्टर है और हम इसको मिला के इस्तेमाल कर रहे हैं 1 2 3 4 5 6, तो वी कैन सेव फ्रॉम 0 to 63। और अगर हम इसको ब्रेक करके सेव कर रहे हैं तो इसका मतलब है कि हम एक डिजिट को 3 बिट्स में और दूसरे डिजिट को भी 3 बिट्स में सेव कर रहे हैं। तो इसका मतलब है कि अब हम सेव कर सकते हैं 77 तक। ऑलराइट, तो सिस्टम जब मिला के कर रहा है तो सबसे बड़ा नंबर आपको 63 मिल रहा है। जब सिस्टम उसको अलग कर करके कर रहा है तो आपको सबसे बड़ा नंबर जो है वो 77 मिल रहा है। ठीक है, अच्छा अब देखें आगे। ये कहता है कि इट वाज डिसाइडेड to split the register so that each digit was represented by its own 3 bits register. What does it mean? That 4 is shown like this and 2 is shown. डिस्कनेक्ट हो गए थे, दोबारा शुरू करते हैं। Alright, so 42 इस तरीके से हुआ है। तो अभी कह रहा है कि what ring has been chosen if the 3-bit registers contain this. So this is 6, 4 plus 2 6, and this one is 0, so 60. So let's go back and see what is at 60. So 60 is chicken soup. Alright, so 60 is what? Chicken soup. 60 is chicken soup. Okay, so the answer would be 60. How would the lemon option be chosen on both types of register? So let's first see what is lemon. So lemon is 52. Okay, so let's see हम lemon को किस तरीके से जो है ना वो represent करेंगे. So 52, lemon is 52. So 5 and 2, that is 52. So 4 plus 1, 5, and then 2, and then 52. So how we will come up with 52? 32 minus 32. Then we have got 20, then minus 16. We have got 4. So it means we cannot subtract 8 from 4, then 4. Then 4 minus 4, that is nothing. So this is 52. So if we put everything together, ठीक हो गया? क्लियर, गुड। चले जी, क्लियर हो गया, अंडरस्टूड हो गया, यस सर हो गया, बेहतरीन हो गया। आगे चलते हैं. Very nice, very nice. Now आगे चलते हैं. What is the advantage of using two 3-bit register rather than one 6-bit register? So I told you that for one 6-bit register, we can save 63 as the highest number choice. For two 3-bit registers, we can save 77 as the highest number choice. All right. So for two 3-bit registers, we can save 77 as the highest number choice, and for one 6-bit registers, we can save 63 as the highest number choice. Now, as we are moving on, the question that we are having are becoming more technical. I would not say difficult, I would say technical. All right. Now, a large hotel uses 8 lifts or elevators to carry passengers between its 60 floors. A computer is used to control and monitor the lifts. Each lift has 3 registers to represent its states. Now, each lift has got how many registers? 3. So the first register, register 1, if it is having 0, it means the lift is going down. If it is 1, it means that the lift is going up. This is the lift ID. So 2 to power 3, that is 8. So from 0 to 7, there are 8 lifts. There are 8 lifts, means we have used what? 3 bits register. So lift number 0 to lift number 7. This is mentioned over here. And then there are 60 floors, 0 to 60. But how many registers do we have? Oh, sorry, how many bits in the register do we have? 1, 2, 3, 1, 2, 3, 4, 5, 6. So 2 to power 6 is actually 64. So 0 to 63. Now you see the highest number of the floor is 60, whereas you can save 63 in it. So there might be a question that asks that what could be the error that may appear. Over here, you have just 1 bit. So this is 2, 0 to 1, and both 0 and 1 are being used. Over here, you have got 8, 0 to 7. So 0 to 7, they all are being used. But over here, you are having 60, but you have limitation of 63. So it means that if the question asks that what is the error, error cannot appear in register 1, error cannot appear in register 2 because all of the values are being used. But error may appear in register 3 for the reason that you have to say from 0 to 60 because these many registers, lifts, floors that we have. But in this particular register, we can save up to 63. So what if someone presses 61? That would be an error. 62, that would be an error. 63, that would be an error. All right, so mind it. ठीक हो गया. तो इसका मतलब ये है कि एक लिफ्ट जो है वो ऊपर जा रही है, लिफ्ट का नंबर 4 है और 16 प्लस 8 24 प्लस 2 26 प्लस 1 वो 27th फ्लोर पर इस वक्त मौजूद है. So this particular arrangement of 3 registers says for the lift number 4, it is going up and currently it is at 27th floor. So what does it mean that this lift is going down? The number of the lift is 4 plus 2, 6 plus 1, 7. And currently it is at 32 plus 16, 48 plus 8, 56 floor. Get the idea? So this lift is actually at floor 56, 32 plus 16, 48 plus 8, 56. So it is at 56th floor. Now, how the following information be shown in 3 registers? Lift 6, 4, 5, 6 is present on 45th floor, 32 plus 8, 40 plus 4, 44 plus 1, 45. So 45th floor. 32 plus 8, 40 plus 4, 45 plus 1, 45. So this is at 45th floor. And it is going down. Okay. That is how you will show it. Get the idea? A customer is on the 14th floor and wants to go to 50th floor. She presses the button to call the lift. What 2 pieces of information would the computer check to identify which of the 8 lifts should be made available? Now, beta, look at this particular question. This question has nothing to do with your syllabus. This question has something to do with your conscious. आपको समझ आएगा, आप अपनी अकल से जवाब देंगे. This is a general purpose question. All right, common sense. This is a common sense based question. All right. So which 2 pieces means हम इस वक्त किस फ्लोर पे हैं और लिफ्ट जो है वो नीचे जा रही है या ऊपर जा रही है. 2 pieces of information that will be necessary for any lift to arrive at floor 14th at which we are present. Either the lift is going up. Obviously the lift which is below 14 and going up towards the 50th floor is the lift that is required. Lift number is not required. So out of 8 lifts, we will see that which one is going up and it is not above 14th floor. So it should be at either floor number 0 to floor number 15 and must be going up. So if a lift is at 14 but going down is not required. सही हो गया. So अब देखें, अब इसके पास 4 options. Using your answers to part 1. Okay, hold on. Using your answer in part 1. So what was your answer in part 1? We need first register and third register. Okay, we need what? First register and third register. Why do we need first register? So that we have an idea that whether the lift is going up or down. Why do we need third register? Because we need to see that which particular floor the current lift is at. We are at floor 14th now. We are currently at floor 14. Okay, so it says that a customer is on 14th floor. She wants to go to 50th floor. So it means she wants to go up. Okay, now this particular lift is going up and currently it is 1, 2, 4, 8, 16, 32. 32 plus 4, 36. Currently it is at 36th floor. So we don't need it because it is already going up and currently it is at 36th floor. We are at floor number 14. Okay, we are at floor 14th. All right, good. Your answer is correct. Let's see. This lift is going down and currently it is at 8 plus 4, 12 plus 2, 14 plus 1, 15th floor. So this is at 15th floor and it is going down. We don't need it. Third one is a lift is going up and currently it is at 32 plus 16, 48 plus 2, 50th floor. So it is already at 50th floor and it's going up. We don't need it. All right. Then it comes to D. D says that a lift is going up and currently it is at 8 plus 2, 10th floor. So this is the lift that we need. So our answer is this, D. All right, so currently this lift is actually going above and currently it is at 10th. Hold on, let me share it once again. Yes, the answer is D. Okay, so our answer is D. Now, an engineer wishes to test that this computer system detects incorrect data. Describe what input the engineer might use to check that the computer can correctly identify a fault. So this is a different question for a different topic, but I told you that in register 1 we won't have any problem, in register 2 we won't have any problem, but in register 3 we may have a problem. So this question's answer will be related to register 3, but since we are not doing it, we will look into it later. Okay, so this is actually related to testing, input testing question, input ranges and testing. We will do it when the topic will come up. Now, letters from the Greek alphabet are to be transferred to a computer system. Each letter can be represented on an 8 by 8 grid. Each column has a value from 1 to 128. All right. The value of each row is stored in a table. So you can see that this is this particular symbol lambda. So it means that whenever it is gray area, we are taking it as 1. So this is 255. You can see over here. I told you that when these are all complete ones, it means that it is 255. All right. Now, this is 255. This is 64 plus 32. 96 plus 4, 100 and 100 and plus 2, 2. That is 102. So this is 102. 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 And you can see that 255, 255, 102, 102, 102, and 102. You can check it over here. Okay, now we have to check for sigma, like this. So let's see. So this is 255. This is 128 plus 64. 128 plus 64. 192. So this is 192. So we write 192 over here. All right, then we have got 64 plus 32. 64 plus 32. 96. So this is 96. We write 96 over here. This one over here is 32 plus 16 means 48. So this is 48. We write 48 over here. This one is again 96. This one is again 192. So 96, 192. This one is again 255. So this is 255 and this is 0. All right, get the idea? Now you will have to create 146 and 84 and 84. So I am just skipping the part B. I'm going further with it so that we could cover more questions. Let's move on. So now this is important. This is an important question. Some decorative lights are made from a cluster of red, green, and blue. If you do remember, I told you that when we create a number, we go from least significant side to most significant side. I told you that, right? 128, 64, 32, 64, 8, 4, 2, 1. But when we read a number, we may read from left to right. My screen is still. Now, is it working? I got out for a moment, but I think I'm back. No. Let me share it again. ठीक है बेटे, अब काम कर रही है स्क्रीन. So when we create a number, our computer reads it. We go from left to right. Okay, so number is actually read from right to left. Okay, so with increasing bits. But when we read a number, this is when we create it. But when we read a number or we judge a number or when we evaluate a number, we go from left to right. So it means that when computer is actually reading a byte, it is going from left to right, means most significant bit side to least significant bit side. You have to keep it in mind. So when the computer will read this byte or this register, it will read this first, then this, then this, then this, then this, then this. Okay, this is what you have to keep in your mind when we are doing this question. So some decorative lights are made from a cluster of red, blue, green, yellow, and white LEDs. Each color is represented by a binary code. So this is red's code, this is blue code, this is green, this is yellow, this is white, this is black. So it means that this is blue. This one is actually blue ke baad green and then yellow, then white and then black. Get the idea? So a 6-bit register R1, the name of the register is R1. This is R1 register. It stores one value to represent the sequence of colors. So this is blue, yellow, and black. This means that blue, yellow, and black color sequence is stored, and remember computer will read blue first, yellow second, and black third. Means it will read it in this order because this one over here is red, then blue, then green, then yellow, then white, and then black. Get the idea? So computer will read the whole thing from left to right, means in order of red, blue, green, yellow, black, white. Sorry, yellow, white, and black. Okay. And then it says that this means that blue, yellow, and black color sequence is stored and displayed in the order. Order, what is order? Left to right. Like this. The length of the time each light is on is set by binary value in another register R2. So it means that if R2 has got this means this is 2. It means that blue light will be lit for 2 seconds, then yellow light will be lit for 2 seconds, and then black will be 2 seconds, and then again the whole thing will restart. So R1 is actually saving the sequence of colors, and R2 is actually saving how many seconds this color would be shown over the LED. Get the idea? All right, so this one is red, blue, green, yellow, white. Red, blue, green, yellow, white, black. So this is red, blue, green, yellow, white, and for how many seconds? 7 seconds. 1, 2, 4. 4 plus 2, 6 plus 1, 7. 7 seconds. So the two registers contain the following values. What is the sequence of colored lights and time for each? So that would be blue, green, white for 7 seconds each. What will the two registers contain if the colored light sequence is red, blue, green, and black? Okay, so red, green, and black, and for 5 seconds. So 1, 2, 4, 5 seconds. What is the problem with trying to display green, blue, red? So Actually, if you could see, so this is actually red, blue, green, yellow, white, and black. So if computer reads it, computer will read red, blue, green. And what they are asking that why computer cannot read from green to blue to red. Because when computer reads from left to right. Because computer reads from left to right. When computer reads the byte, the register, it reads from left to right. That is red, blue, green, and cannot go right to left. That is actually the problem. What is the problem? So I have defined that when computer reads the register, it reads from left to right, that is red, blue, green, and cannot go right to left, means it cannot read green first and then blue and then red. Get the idea? So now move on. So can you explain how the register is blue, then yellow, and then black? I told you that when computer reads, it reads from left to right. So first it will be lit at blue and then green and then yellow. I mean white, not yellow. Okay? And every single color will be lit for 7 seconds. So it is reading from left to right, and 0, no color, then blue, then green, then 0, no color, then white. That is how. Now this is the most important part. See, with every single question you are learning something new, and that is not defined in any book, that is not defined in your syllabus, that is just your common sense that you have to learn it. Okay, now this particular question is bit shifting.